So let's talk a little bit about set notation and things like that. So some terminology to begin with. So a set, a collection of objects. Those objects we call elements. So some language we use when it comes to sets. We can have what's called a listing set, where it simply lists all the objects in the set, or all the elements in the set. Or I could use a describing set, where instead of listing the elements, a description of the elements is there. So these two are the same set. The first one, 1, 3, 5, I've done a list, whereas the second one, I've just described it. Oh, it's the first three odd numbers. So two different ways we could write a set down. Equal sets are ones that contain exactly the same elements. So if B is the set 5, 3, 1, then A and B would be equal. They both contain the same elements. It doesn't matter the order that I write them down. The empty set is a set which has nothing in it, hence why it's empty. You might sometimes see that called the null set. The universal set is like the other end of the scale, where it contains everything. So hence the universal set contains every possible element. Now when we're talking about probability, that's the same as the sample space. The sample space contains every possible event. A subset, a set that is contained within another set. So C, if I said C was simply the set 5, well, it's a subset of both A and B. We can find it inside those sets. Then intersection, well, that's the elements that they have in common. So they overlap. So if D is 2, 3, 4, then the intersection of A and D would be the set 3. It's the element that's in both of those sets. Okay. Union is when we combine two sets. So using those same examples before, if I can do the union of A and D, it now would be the set 1, 2, 3, 4, 5. Because we can find those elements either in the set A or the set D. It might be in both. But we can find all those elements in these two sets. Complements, they're the ones that are not in the set. So if the universal set is, well, for my example, I've said the first 6 integers, then the complement of A would be 2, 4, 6. Because A was 1, 3, 5. So the elements that are in the universal set, but not in set A, are 2, 4, 6. Notation. Null is like a 0 with a slash through it. So that represents null, which is the empty set, or you might simply do the braces. We usually write contain sets within braces. So if I've got a set of braces there and there's nothing in it, we're talking about the empty set. What looks like an E, I suppose, but that is an element of. So that stands for an element of. So 3 is an element of A. The absolute value symbols we saw before when we were looking at probability. But another way you could write it is simply N and then in parentheses of what it is that you're trying to count. But the number of elements in the set. So set A had three things in it. The sideways U there, that stands for is a subset of. So we said C was a subset of A, C was also a subset of B. B was not only a subset of A, but it also was an equal set to A. So you get an equal and subset sign on that one. And here's the interesting one. The empty set is a subset of A. The empty set is in fact a subset of every set, because you can find nothing in everything. Weird, hey? The upside down U symbol stands for intersection, and the U that looks like a U stands for union. Complement, just like we saw with probability, the bar on the top, but other ways we could write it is A with a dash, or A with a C written on it, standing for complement. They're probably rarer. The one with the bar on the top is the one we see most often. Okay, Venn diagrams. So Venn diagrams are another way of writing all the elements or the sample spaces if we're talking about probability. So it's a visual or a geometrical way of writing our sets down. The universal set we usually represent with a rectangle. You may remember back when we looked at the real number set, I put it in a rectangle. Because I said, well, what I'm basically saying is that's the universal set of numbers. So here's an example of the universal set I've drawn in blue, and then a few other sets are in there as well. If I wanted to illustrate here that C is a subset of B, if I look at that universal set, what I've done is I've shaded in the set B, but to illustrate C is a subset, you see I've left that blank. But subset means contained within. That's what I'm basically illustrating with that diagram. Intersection then is the overlapping part. So that's the bit I've shaded in for that one. Union would be both of them shaded. So we're saying everything that's in both of those sets. Union of, in fact, that's so good I'll put it down again. Why is that there twice? I have no idea why that's there twice. Disjoint sets. Disjoint sets are like mutually exclusive. Remember, we said they can't both happen at the same time. So C and D, there is no overlap. There's nothing that is in both sets at the same time, so they are disjoint sets. So how do we use these Venn diagrams to count sample spaces and solve problems? So, here's the rule, by the way. The number of elements in A union B will always be the number of elements in A plus the number of elements in B, but take away the number of elements in the intersection. Because when you count A and you count B, you've double counted the ones that are in both. So you've got to take away that intersection. So we'll go to last year's HSC. They had a question. History and geography are two of the subjects students may decide to study. And there's a group of 40 students. The following is known. 7 of these students study neither history nor geography. 20 study history and 18 study geography. A student's chosen at random. By using a Venn diagram, so they're tying your hands, although they do say or otherwise, so it does give you an out if you didn't want to use a Venn diagram. Find the probability that the student studies both history and geography. So I've drawn in a universal set, and the two things I'm interested here is geography and history. And I've just drawn them. Now, the question is, where do we put everyone? Or how many people are in there? Okay, well, I can work out that there's 7 that are not in either. Now, that's because, where's the information they gave me? 7 students study neither history or geography. So I know there must be 7 out there. Okay, let's calculate what's missing then. Remember, there's my formula. The union will be the amount in G plus the amount in H minus the intersection. So I can now work out how many is in the intersection. Right? Because the union will have 33. There were 40 students all up, remember? 40 all up. Well, if 7 aren't in there, there must be 33 in the union. They told me 18 are doing geography and 20 are doing history. So a little bit of algebra there. We can work out, there's 5 in the intersection. So I can put that in there. And I can now complete where everything else is. Because if I know there are 20 doing history and 5 are in the intersection, well, that must put 15 in that section there. And similarly for geography, we can work out 13 are in that section. I should now be able to solve any probability question. Find the probability that they study both history and geography. Well, we now know there are 5 in the intersection. So 5 out of 40, 1 in 8. A student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? So basically, remember what I was saying on Friday? Don't just write a number down. Explain what you're doing. I'm finding the probability that the geography student doesn't study history. Well, now it's out of 18 because we know they study geography. So my sample space is the geography set now. So there's 18 all up. 13 of them don't study history. 2 different students are chosen at random, one after the other. Well, what's the probability that the first one studies history and the second student does not study history? So probability, we get a history and a not history, but it has to be in that order, they're saying to me. Well, again, I can now just read off my Venn diagram. There are 40 all up in the universal set. 20 of them were studying history, so 20 out of 40 times how many do not study history. It'll be 20 out of, but now it's out of 39 because we've already selected one person. So we get 10 out of 39. 12C and 12D. Enjoy, because I know you will.